For first of all, we would go today for the filtration topic, basically, which is used to separate an insoluble solid from a liquid. So there are two things that needs to be there for a filtration technique to be followed. One is that in the solution, there should be an insoluble solid, and then there should be a liquid that acts as a solvent. Insoluble solid obviously would be acting as a solute, and the liquid would be acting as a solvent. So if it is not soluble, if the solute is insoluble, what would happen? When the liquid, we would pass it through a filter paper. The insoluble residue or the insoluble part of the solution, or of the liquid, it would remain on the upper surface, or it would retain onto the filter paper, and the pure liquid, it would be passed into the beaker or into the funnel. So the apparatus we have used here is there is a filter paper, then there is a filter funnel, and there is a beaker to collect that pure liquid. Or so what would we have, what would happen here? The liquid has been passed through this funnel after passing through the filter paper, and this is called a residue that is retained onto the filter paper, and this is called filtrate. Filtrate is that liquid, that pure liquid that is collected after filtration has been done. Now, the next is crystallization. Crystallization is basically interesting technique, and normally it is used after the filtration to purify the liquids. How do we do that? Basically, we remove water from a solution which contains an ionic compound, anything salt like copper sulfate, like sodium chloride, like magnesium sulfate. So every type of chlorides and sulfates, they are basically salts. So we remove those salts from water using method of crystallization. How does it work? We know that the water, it has a lower boiling point as compared to the salts. Sodium chloride, it has more boiling point than water. Magnesium sulfates, copper sulfate, magnesium chloride, they all have more boiling points than water. So this is again the separation technique on the basis of boiling points. What do we do? The evaporation can easily be carried out. How? We are going to heat the sample in an evaporating basin. We are going to heat the sample. So when we are going to heat the sample, the boiling water, what it would happen? We would avoid the overheating of the boiling water. Why? Because it would prevent the material from being lost. So we would slowly heating that liquid, that solution, so that it would help us out to separate the required material. When it is boiled, it would after reaching at its boiling point, what would we do? We would left, or we would leave it into the lab, so that once the water is evaporated and only the saturated solution of the salt is there, what would we do? We would leave it there as it is and wait for the liquid to cool and to come to the room temperature. Once the room temperature it is achieved, that same salt, they would convert itself into the crystals. And what would we do after that? Once the crystals are there, we would collect the remaining water or the remaining solution by using the simple filter paper. We would put that filter paper and we would pass that solution from the filter paper, and the crystals would be there. Those crystals, obviously, they would be pure salt crystals. So we can use whatever the use we would. So we can use it for the purpose whatever the purpose we have. Like if sodium chloride is not being separated, Although sodium chloride can be separated, but yeah, if you are going to use a crystallization method, so you can and you want to separate the sodium chloride from the solution, you can follow the same method as we have discussed. That was crystallization. Then comes the distillation. This is further advanced technique, which is called distillation. Because there are two types of distillations. One is simple distillation, and the other one is fractional distillation. Fractional distillation is further advanced technique. What is simple distillation? Simple distillation is basically used to separate the solvent from any solution, and from any solution means the situation or the circumstances of the solution is that the containing the solute is there, it is dissolved. In case of um, in case of filtration, we have insoluble solute there, but the distillation would be performed in that scenario in which the solute is already dissolved into the liquid. Like if you pour sodium chloride into the water, what would happen? After stirring some time, that sodium chloride would be dissolved. So if you want to separate that sodium chloride, what you can use the method of simple distillation. We can, how the boiling point of the liquid, it is normally lower than that of the dissolved solid. Normally the dissolved solid, they are salts normally. When we are separating, following separating separation techniques, normally we are separating solids, like salts, from the liquids, even in case of sea waters as well. So that dissolved solid, they have higher boiling points that we have already discussed in case of the in previous techniques on the basis of boiling point. So what would happen? The liquid solvent, obviously it is more volatile. Volatile means it would be evaporated earlier than the solid. So being volatile, the dissolved solid would remain there, and the liquid, the solvent, you can say, it would be evaporated. What is anti-bumping granules? Anti-bumping granules, they are small granules that basically help to reduce the size of the bubbles. And why do we need these anti-bumping granules? Because it is used for the safety to stop the flask shaking. Because if the flask is being shaken, it would disturb your experiment. Solvent vapors, they are condensed. The solvent vapors, they are those vapors that have been evaporated during the distillation process. So because you are here to, let's say, your purpose is to collect water. Your purpose is to collect water, pure water. You want to use pure water. You want to consume it, or you want to pack those water into the bottle, and you are going to install a big purification plant, and you are saying that I am going to follow the method of distillation to purify the water. So obviously you need water. That is your ultimate product. So once you have separated the solid or the salt from that water, what you would do? The water is evaporated. So to gain that water again, you would be performing the condensation method. You would be dropping the temperature of that water vapors, and because you have to pass those water vapors through a condenser. Once they are condensed, they would be converted into water again, and once they are converted into water, liquid water again, they would be collected in the beaker. This is how distillation happens. Look at this diagram. This is the flask you are heating it, and this is a thermometer that has been installed up there onto the flask. When, again, look at this, seawater has been used. Yes, they are separating salts from the water. Ultimate purpose is collection of water here. So you are using thermometer to measure the temperature. Once the temperature reached to the 100 degrees Celsius, you would get to know that there are fumes that are being seen here. That means the water would start converted into water vapors. After that, there is an entry or exit, you can say. Those water vapors would start moving through this opening from the cork to this point. There is a water condenser here. When those water vapors would pass through this condenser, it would move to this. After condensation, it would convert itself into the liquid water and would be collected into the beaker, which is here, and we can use that water. This is called a distillation process. Clear? Any confusion about that? Okay, let's have a video about crystallization and distillation.
That we can use to separate out mixtures that contain liquids. Let's start with simple distillation, which is used for separating out a liquid from a solution. For example, we could use simple distillation to separate pure water from seawater. Before we cover how it works though, we need to be familiar with the equipment. First, we have a flask that contains the solution or the liquid mixture that we're trying to separate. And the flask is sealed at the top with a bung so that no gas can escape. We then put a thermometer through the bung so that we can measure the temperature inside the flask. Next, we have our condenser, which consists of a main pipe surrounded by a water jacket, which contains a stream of continually flowing cold water, with the water being fed into the water jacket at the bottom and coming out at the top. Then, beneath the end of our condenser, we'll have some sort of beaker to capture our pure liquid. And finally, we're going to need some sort of heating device, like a Bunsen burner, which we place under the flask. Our first step is to heat up the mixture, so that the liquid that we want evaporates. As it rises to the top of the flask, the pressure will force it down the condenser. And because we're pumping cold water through the water jacket, the vapor will cool and condense into liquid form, which will then run down the pipe and collect in the beaker. So in our case, as we heat the seawater, we'll get more and more pure distilled water, until eventually all we have left in the flask is salt. Now imagine instead that we were trying this technique with a different mixture, one containing some different liquids, like methanol, ethanol, and propanol. Because these liquids all have similar boiling points, when we heat them, more than one of them will evaporate, and so they won't be separated into pure substances. In this case, we'd have to use a different technique called fractional distillation, which is the main technique used for separating mixtures of liquids. The equipment for this is pretty similar, but instead of the gas passing straight from the flask into the condenser, the vapors have to first pass through a fractionating column, which has two key features. One is that it's full of little glass rods, which provide a really high surface area. And the other is that because the column is so tall, it's actually cooler at the top than it is at the bottom. To understand why this is important, let's imagine that we were trying to separate those three liquids that we mentioned before: methanol, ethanol, and propanol, which all have similar boiling points, although you don't need to remember them. And before we continue, just be aware that in real life, these would all be colorless, not green. We're just showing them as green to make it easier to follow along. Now, because methanol has the lowest boiling point, we'd heat the mixture to around 65 degrees first. This would cause the methanol to evaporate and then rise up the fractionating column. It would then pass into the condenser and condense into liquid methanol, which we would then collect in our beaker. However, just by chance, some of the ethanol and maybe even propanol would also evaporate. But as they rise up the fractionating column and come into contact with all of those glass rods, which are much cooler than their boiling point, they'd condense back into liquid form and fall back into the flask. This means that the only liquid that will get out the other side will be pure methanol. The next step would be to do the same thing all over again for ethanol, by raising the temperature to around 78 degrees Celsius, which would allow us to evaporate off the ethanol. At this point, all that should be left is the propanol. So we could just assume that what we have in the flask is pure propanol. Or we could raise the temperature again to boil off the propanol, just to make sure. Anyway, that's all for today. So hope you...
So that was fractional distillation and distillation. And now let's have a bit understanding of crystallization through a video. Yeah. It would also contain the filtration part as well.
At the end of this video, you should be able to describe physical separation techniques. Now, there are several different physical separation techniques, but in this video, we're going to focus on filtration and crystallization. They can be used to separate mixtures. They cannot be used to separate the elements in a compound. In a later topic, we look at how we separate the elements in compounds, for example, by chemical reactions such as reduction or by electrolysis. In this video, we're focusing on physical separation techniques and how they're used to separate mixtures. We're going to start by looking at one of the simplest separation techniques, which is filtration. Filtration is used to separate an insoluble solid from a liquid. And the word insoluble means that the solid will not dissolve in the liquid. I'm showing you here the chemicals silver chloride and water. You'll notice that I've also included lowercase letters next to the formula of each chemical. These are called state symbols. State symbols tell us the physical state of a chemical. For example, whether it's a solid, a liquid, a gas, or dissolved in water. The S tells us that silver chloride is a solid, and the L tells us that water is a liquid. Now, silver chloride is insoluble in water. In other words, silver chloride will not dissolve in water. And in the AQA exam, you'll be given any solubilities that you need to know. So I have a solid material suspended in a liquid, and I'm showing you that here. Now, in reality, you would not be able to see individual particles of silver chloride, but it does illustrate the idea. So because this silver chloride is insoluble in water, we can use filtration to separate these two substances. To do this, we use a filter funnel and a filter paper like this. We start by pouring our mixture into the filter paper. The liquid, in this case the water, passes through the tiny pores in the filter paper, and scientists call this liquid the filtrate. However, the solid material, in this case the silver chloride, cannot pass through the filter paper, so it's trapped. At the end, we have our liquid separated from our solid. So as we've seen, filtration separates an insoluble solid from a liquid. Filtration is a really useful physical separation technique, and it's used a lot in chemistry. Another important physical separation technique is crystallization. Crystallization is used to separate a soluble solid from a liquid. In this example, we have sodium chloride and water. Sodium chloride is soluble.
One thing you should always know about these techniques, because sometimes the examiner asks the question in this way that what are the principles, working principles of, let's say, crystallization, difference in the working principle of crystallization and filtration as well as the distillation. So there are the number one difference, the first difference in the conditions is based on insoluble solid into the liquid, that was for the filtration, then the crystallization, and then the distillation for the obviously the soluble solid into the solvent. So you must have you must know about the differences about these in these three different processes.
And water. So when we mix sodium chloride with water, the sodium chloride dissolves and we form sodium chloride solution. The state symbol AQ means that the sodium chloride is dissolved in water, and scientists call this an aqueous solution. Imagine that we want to separate the sodium chloride from the water. So here's our sodium chloride solution. Now, if we leave this solution for a few days, then the water will evaporate, and this will leave behind crystals of solid sodium chloride like this. You can see that I've changed the state symbol for the sodium chloride from AQ to S. That's because the sodium chloride is no longer dissolved in water, it's now a solid. We can make crystallization happen faster by gently heating our solution to evaporate the water. However, we do need to be careful. Certain chemicals will break down if we heat them. So sometimes it's better to allow the water to evaporate on its own. You'll find plenty of questions on this topic in my revision workbook, which you can get by clicking on.
So this was about crystallization, filtration, as well as in the video, the fractional distillation was also discussed. And this was the basic techniques that we often use in for the separation of different types of solutes and solutes and solvents like. There is another thing that look at this: component one, component two, technique and example. Solid, if the solid into solid, it is not a solution, it is kind of a mixture. So this is what he is doing is he is separating sand from the sodium chloride. Then there is insoluble solid with the liquid. So we would use the filtration, and then there is soluble solid with the liquid. Then we use the crystallization, copper 2 sulfate from water, magnesium sulfate, even copper chloride, magnesium chloride, etc. Then there is liquid miscible distillation. We can use distillation and fractional distillation to separate on the basis of different boiling points. The questions can be asked in this way: select the correct separation technique. Obviously, you would have been given the scenarios, the circumstances regarding the chemical compounds, like you have been given, let's say, the solute and the solvent, maybe in the liquid, both are in the liquid state or both are in the solid state. One is in the solid state and the other one is in the liquid state. So this is how the circumstances would be there, the scenario would be there, and you are going to select the separation technique. Testing purity by melting point analysis. So what is this? How can we test purity by melting point analysis? Basically, the previous techniques that we have discussed, it was to basically collect the pure substances from a liquid or from solution or mixture, you can say. So what would be a simple test for the purity? What would we do? We are going to measure boiling and melting points of the same chemical compound. This we have also discussed when we were discussing the heating curve in chapter 1 in the previous lectures, and how you can judge that the substance is pure or not. So simply you are going to heat it, and you are going to check the melting and the boiling points. If they are as per the standard melting and boiling points, that means they are pure. So if they are not pure, if they are impure, obviously the melting point is going to be changed and the boiling point is also going to be changed. So that was a simple test. The important technique, which is a very modern separation technique, it is called paper chromatography. Chromatography or the paper chromatography. Basically, it was how it was developed. It was developed for separating soluble pigments. The very need for this type of technique is the substance should be colored substances like dyes, like inks. So how can we use this technique? We can use this method by using filter paper. But it is to be ensured that the substance should be colored. How they will separate? They would separate only if the pigments have different solubilities in the solvent. Like if you are, let's say, you are dissolving copper sulfate and sodium chloride into the water, and they are dissolved. Once they are dissolved, but they are dissolved, and they to dissolve they have taken different amount of time. Let's say if you are talking about sodium chloride, it would dissolve within 5 minutes, and if you are talking about other solute, it must, let's say, it takes almost 15 to 20 minutes to dissolve into the solution. So they must have different solubilities in the same solvent. Then the pigments have different degrees of attraction for the filter paper. What is the degree of attraction for the filter paper? It means that it should pass through the filter paper. The time it is taking, it should be different while passing through the filter paper. That is called degree of attraction for the filter paper. These two factors would determine then how fast the pigments move across the filter paper. Now, what you are going to do, you are going to have a drop of concentrated solution, and we are going to place on a pencil line. We would call it as the base line or the origin line with near to the bottom of the edge of a strip of chromatography paper. This is a chromatography paper. That is baseline. Now, after it is the baseline is drawn, now it is not going to interfere with the separation. Now what would we do? The paper would then be dipped into the solvent. The filter paper, it is then dipped into the solvent. After that, look at this here. This has been dissolved into the liquid. The level of the solvent, obviously, it should be below the sample. That is the baseline. And when you have dissolved it, it is below the sample. Now the substances, they separate according to their solubility, as we have already discussed in while we were discussing about the factors, that they should have or they must have different solubilities. So if they must have different solubilities, what would happen? As the solvent would move up the paper, those substances, they are also carried with it. When they are carried with it, they would start to begin to separate. What is most soluble, it was moves faster through the paper. Which is less soluble, it would moves obviously the slower. So chromatography, it is run. Once it is run, after that, there would be a stage when we stop the procedure, and that stage is when the solvent front reaches the top of the paper. The pattern that is developed here, this is the pattern. This is called the chromatogram. These are basically those substances that have been separated on the basis of solubility of the liquid. Before getting into the RF value and the locating agent, let's have a visual understanding of the chromatography.